Hello everyone. So today we're going to talk about limits with trig functions. And so here I'm just recalling some identities and definitions from pre-calculus that are going to be important in terms of figuring out the limit of trig functions. So the first one is just the cosine squared of x plus sine squared of x is equal to 1. Alright, so this one's really important. This one's also used a lot, and so you might see something like it written in a different form, like you might see something like sine squared x is equal to 1 minus cosine squared x, or you might see that cosine squared x is equal to 1 minus sine squared x. Okay, because really these things that I'm writing are super important for you to remember. Okay, and the things that I just wrote really just come from this bullet point here, this identity. Okay, and then the other ones here are just me showing you, okay, how do we define tangent of x? Well, we just say that that's sine over cosine, and then cotangent would be cosine over sine. Remember that secant is 1 over cosine, and then cosecant is 1 over sine. Alright, and so now we have two important trigonometric limits. Alright, and so the first one I showed to you on day 1, when we started talking about limits, I convinced you numerically what that limit was, and so that limit was actually 1. So the limit as x approaches 0 of sine of x over x is 1. The second important trigonometric limit is the limit as x approaches 0 of 1 minus cosine of x over x, and that's equal to 0. And so the second one actually comes from the first one. It's not super obvious. There's a lot of algebra going on there. And so if you are interested, I will show you that. I'll post on the Teams page me showing out like where that comes from. But if you're okay with just knowing, okay, these are the two important trigonometric limits and moving on, then that's fine too. So the other thing I wanted to bring up to you is that when you're looking at these important trigonometric limits, what's actually true is that the limit as x approaches 0 of sine of whatever is in my parentheses over that same quantity that's in my parentheses is also equal to 1. And the same thing holds for the 1 minus cosine x over x. Alright, and so I was saying, in other words, what is inside the parentheses has to match the denominator, alright, in order for you to say, okay, well, it's equal to 1 in terms of like the sine of parentheses over parentheses, and then the limit as x approaches 0 for 1 minus cosine of parentheses over parentheses, that's equal to 0. So the idea again is that the what's inside the parentheses has to match in the denominator in order for you to use this important trigonometric limit.